And as Dr. Gardner had said over email, it will be due on the last day of class. So there's plenty of time for you to ask questions. So homework 3, this was doing differential equations like change of concentration in respect to time, right? For homework 4, instead of the changing concentration with respect to time, we're going to be looking at it with respect to position. So we're doing boundary value problems in MATLAB. So it's just, for example, like diffusion through physical space. And in the online, I believe we should have already published the starter code for this. It should be BVP, either BVP demo or just starter code. But that starter code will be only defining one species changing. However, if you know on the homework itself, you will be looking at more than one species. So you're going to have to rewrite the functions just a little bit differently because you need to add on to account for the change in the second species. So, yeah. Have any of you used the boundary value problem solver in MATLAB before, or like any other coding? All right. That's exactly why we're giving you guys extra time, because syntax is very important for the boundary value problem solver. So this is to define the function for our differential equations. I'm going to just sweep through here. So one of the things with these boundary value problems is that with the differential equations that we're specifying in the problems, they are written as second order derivatives, or like second derivatives of that species in respect to x. MATLAB doesn't really take in the second derivative, so what you have to do is to rewrite that second derivative into a system of two first derivative equations. Yeah, so I don't think we have like a section specifically talking about that, but I can definitely go over that during office hours if you're unclear. But MATLAB does have documentation on how to rewrite a second derivative into a system of two first derivative equations. And so even though this is looking at one species, we will have to define two first derivative equations for that species. And this is just, these two equations are really just rewriting that second derivative of species A's change over the change in x. And we're going, like how in the last homework we used one of the ODE solver functions, we're using that for the ODE. We're using something similar for the ODE function that we're defining here, but instead of like ODE 45, we're using ODE fun and putting it into an array that we define as dy dx. And then that array is going to be fed into what was in our top level script in, I believe it was sx int. So it's just a lot of arrays within arrays, and they will call that a structure. So yeah, the thing is, this is where the syntax is going to matter a lot. So in here, for species A, we only have the second derivative written as I said, the two first derivative equations. When we have, for example, two species, that means that you're going to have to write two first derivative equations for both those species. So that would be 4 equations in that array. How you define those equations will matter, because MATLAB will not know which one you're trying to write. It will just take it in as species A. So like the derivatives or the equations related to the first species, and then the next chunk would be the equations related to the next species. if you mix it up, it's still going to read it like that, and it will calculate the change in concentration differently than what you're supposed to get. So just keep that in mind. Was that confusing? Or kind of? Yeah, I would say that it's difficult to kind of envision that when you're just looking at the script with one species. But I would definitely suggest trying your hands on incorporating a second species, and when you're getting stuck, which will happen quite often for these boundary value problems in MATLAB. As I said, we have an extra week for you guys to do this homework, so definitely send me questions, read the MATLAB documentation, and go to office hours. So the function that we're going to define our boundary conditions, that would be the BC fun, so that's the boundary condition function. And we have, again, because we are calling it in two y values, we have to define our constants within the function. And one of the tricky things here is that with YA and YB, that does not correspond to the Y of species A or the Y of species B. It's so YA is specifying the left boundary condition, and YB specifies the right boundary condition. So you're going to have to pay careful attention to what is in those arrays. So YA1 is going to correspond to the Y of species A at that left boundary condition, whereas YB2, well, we only are looking at species A here. That too would, that second value in the YB array for the boundary condition, that is related to a differential equation. So the arrays, the way MATLAB defines the arrays is going to be very confusing. Definitely write down write out the differential equations by hand on paper. And what helped me out especially was to make like a glossary of this Y sub whatever species is equivalent to like how it's going to be defined in MATLAB, just to keep track of the differences between how you're calling them like on paper or how you're solving them on paper versus how you're supposed to define them in MATLAB. So yeah, and then the rest of it is just making sure that the output array is going to be outputted from this function, and both of these functions are going to be fed up into that top level script. And again, the way that we're defining those series of equations is that the first chunk will be related to the first species, and then the next chunk is related to the next species. Are there questions at this time? Yes?
Can you tell me once again what is YA1 and YB2?
So YA, just like the whole array of YA, is the left boundary condition, while the whole array of YB would be the right boundary conditions. There will be like YA1, YA2, and so on. Those, from what I can recall, it would be that one, so the odd numbers would be corresponding to the first, either the first derivative, and then the even numbers correspond to the second derivative. It kind of does not make a whole bunch of sense, but and by like even and odd, I mean like the numbers within the parentheses, and those are just alternating between the different species that we would be defining. Anything else at this moment? All right.